Hey, welcome! You are here with Change Models 101. I'm Nicola Graham for Be Change Limited, and I thought I would like to give you the lowdown on my top 10 chosen change models throughout the last century. I would like to explain to you the history of these, how and why they were created. I'd like to give you the explanation of each model in hopefully a simple way. While we're at it, why not go for the pros and cons for each one? There's no harm in that. And how about a case study just for you so that you can understand if these are useful for you in your projects today. We're giving this content for free, guys. You go ahead, click and subscribe to our channel for more useful information. Let's get going. Hello everyone and welcome to Change Models 101. I am Nicola Graham from Be Change, and we are here today to explore the Six Sigma change model. The Six Sigma change model is actually a data-driven approach to change. It's focusing on eliminating defects, and it helps with improving quality within a process. Now, the history of the Six Sigma, it was actually developed in the mid-1980s, and it was developed by a man named Bill Smith. He worked for Motorola. Bill Smith was asked by Motorola, his employer, to actually help them create something that was going to improve their manufacturing process. They had had so many complaints at that time about the product quality, they decided they had to make a difference, and there needed to be a way where they could find a solution to improve that. They actually had a goal that they wanted to limit their defects to be no more than 3.4 defects per million products sold. OMG, that is practically impossible. But they wanted to do it anyway. Fun fact, do you know Motorola was the first company who actually created the hand mobile? Yep, that's right, in 1973 it was created by Motorola. Okay, so let's go ahead and explain exactly how this model works. Be right back. Ta-da! So what is Six Sigma? Six Sigma is a set of tools and techniques that have been designed so that you can improve the processes that you currently have, but you can also focus on almost near perfect quality, okay? And essentially it's a set of guidelines, I like to explain it as. And those guidelines have actually been acronymed into two ways. Now, there are two ways that you can use Six Sigma. You can use them for a process that you want to improve on, and you can also use it for something you want to create as new. And in these scenarios, there are slight changes to the guidelines that you use. So if you're looking to improve an existing process, you can use the acronym known as DMAIC, probably saying that wrong, DMAIC. If you're looking to create something new, you can use the process and follow the guides around DMADV, DMADV. So there are some nuances between the two, but we're going to kind of bounce them around and go between one and the other. If you're looking to improve a process, you start with your D, which is define. It's around defining the problem that you currently have and seeking objectives. What is the problem today and what do we want to do about it? How do we want to overcome this? So it's defining that at that stage. And at that point, you can then move on into the M, which is measure. Measure is around measuring the current key aspects of your existing processes and collecting data points on them. Okay, so we've got this problem. We want to understand how to improve it, but what is the actual problem? Let's collect that data. So we're going to measure that. The next stage is analysing, and that focuses on getting that data that we've collected and measured, and then analysing it to understand truly what is the cause and effect of that problem. What is that problem and why is it happening? Then you go into your I, which is around improving it. So it's looking at optimising your current processes to ensure that you can find ways by where you can improve your existing problem. And then finally you have your C, which is control, and the control is around correcting any deviations from your existing process before they actually turn into defects. For example, if you recognise that actually during this data that you can improve something along the process before it actually gets to a defect. Let's say if it's a manufacturing plant and it turned out that some of the defects were happening because the plastic was breaking, actually maybe there has been a recognized data point where you can improve, say, the quality of the machinery or oil it, or I don't know much about manufacturing. But essentially you want to understand that control that you can do before it becomes a defect. That's for existing. Now, if you want to go into a new, you still have similar things. You define, but you're now defining the goals and aligning that with the need. What is it we want to achieve and why do we want to achieve it? Then you go into the M, which is again measure, but it's measure and identify. And that's around exactly what you want to identify as the measurements that you need to achieve as part of this. So for example, product capability would be one of it, the actual quality, the CTQs, the processes, the risk. You would define at that point exactly what those measurements would be for you. You then analyze the same as before, but you're going to design, you're going to analyze the development and the design at that part. You're going to look at different options at this point and think, do we want this design or that design, and which ones might be better for us? And once you know that, you go into the D, which is design. And design in that means that you're actually going to choose the best design suited. Back in the analyzing stage, you're going to choose that design at this point and you're going to run with it. And then you go into V, which is verify, and the verification is around verifying it with the process owner. So whomever has come to you with the original goal that you need to define is the one that you need to verify that with. That is Six Sigma on a page. Now, let's go and look at a case study. I promise you I'm not very good at drawing, but we're gonna try. So our case study today is going to be focused on a hospital. Might look a bit more like a prison. Okay, so this hospital currently has very sad people because the waiting times are too long. People are getting unhappy at the hospital because it takes too long to be seen. So, in this scenario, this is an existing process, and therefore we're going to use our first one, which is improving processes, which is our DMAC. In this scenario, we wish to define the problem. Well, the problem is people are waiting too long. They're very unhappy, and we can't continue to run a hospital where people are going to complain about us. So, we recognize the problem, that's the problem. Now let's think about the solution. The solution is we improve our processes so that we can make people happy and reduce their time. At that time, we need to measure. So what are we measuring? We're measuring where the time is breaking down, where in the process time is breaking down. So we're going to start collecting data. We're going to understand when somebody walks through the hospital and then walks out of the hospital, how long that whole process takes for them. And from this data, we can then go on to analyze. And the analytics of that, maybe an S, we're in the UK. We're going to analyze, and then we're going to analyze that data to understand exactly where the breakpoints are. So we've defined our problem, we know what our solution is, we measure exactly where the problem is being created, we analyze that data that we've collected to understand better where in the hospital that's broken down, then we improve. So we look at, okay, if we improve that bit, that's going to save X time. And if we improve that bit, that's going to save Y time. And then finally, we measure the controls. So in this scenario, we've looked at the improvements that we can potentially make. And then we would want to understand from the control, if we don't do that, then actually the defect happens, people have to wait too long. That is a good case for using DMAC. It also works, remember, agnostically across different industries. So you could use this scenario I've used it in several scenarios when you've been defining a new solution, a new technical solution. It gives you that structure to be able to define what it is you want to do, set those goals, measure and apply measurements to those, analyze the data to ensure that it will work, and then go on to design that, or choose the best design, should we say, and then verify it with the business. That is Six Sigma explained, and I hope that you can use that in any of your projects today. Don't forget to subscribe for more. Over and out. And that's a wrap. I hope you enjoyed today's content. Don't forget, guys, click and subscribe for more content coming your way very soon. And whilst you're at it, how about something free of charge? Yeah, that's right. I said free of charge. Sign up now, www.bechange.co.uk, where we are giving you a free change management course. That's right, the Build, Excite, Equip Foundation course, where we will educate you within 2 hours exactly why change management is crucial to project teams, but also how project teams can do this role within their existing activities. That's right, you truly can take people on that journey with you in your projects, and you can improve your project success. I promise you improved return on investment. Check it out today. Bye-bye.